Hi, welcome to the lecture 26 of week 6 of the course Introduction to Language and Linguistics. This is Dripta and the title of today's talk is Different Parts of a Tree. Today we will be talking about different parts of a tree. We will know their names and how they work, and we will talk about different relations between certain labels. For example, we will be talking about branch, node and some more structural relations which are needed for advanced analysis as well. So, we already know about the concepts that I have put under the bullet points. So, we know that constituents are group of words that function as units, and we have a set of rules for them, and the rules generate trees which represent constituency. So, today our call is to talk about different relations in a tree. Now, you know how to draw trees. You have also drawn some slightly complicated trees, right? And now, let us talk about the organization. You can say that the parts of tree are organized hierarchically. Earlier we talked about the fact that you can draw a sentence in terms of a linear string or a hierarchical tree, right. So, if you think about a tree, you talk about some kind of hierarchy, and then there is a collection of lines and labels with an internal organization in the tree. So, you can consider the tree as a geometric object. Why we are saying a geometric object? Because it has some bits which are spatially organized in relation to one another. Okay. So, we can assign names to different parts of a tree, and we can describe how they are related to each other. And there are certain syntactic phenomena that makes reference to the geometry of the tree. So, here is an example of a tree, and you can think about different xp's or x's or x bars here. So, this is an abstract tree, right. We have not used n, v, etc., and we can create the very simple and basic rules for the tree. A goes to B and C, B goes to D, E and F, and C goes to G, H and I. So, now we will be talking about branches and nodes of a tree. Trees have branches, right. I mean, so we are borrowing the term from a real tree. So, there are certain lines in the tree. When you are drawing a tree, you are definitely drawing a lot of lines. So, these lines of tree are known as branches. So, you can define a branch as the following. A branch is a line that connects two parts of a tree. The end of any branch is called a node. So, and what do you mean by end of any branch? You can think about any label that can be put there, and I am sure you are basically trying to visualize a tree, maybe the tree that I have drawn, and basically you can define nodes as the nodes at the end of branches. So, we have branching nodes and non-branching nodes. You can say a node with two or more branches below are branching nodes, and nodes that have a single branch below is a non-branching node. So, now I am asking you to figure out the branches and nodes in the tree that we have drawn previously. If you can go back to the tree and figure out simply which are the branches and nodes. Now, we will talk about some labels. So, nodes of a tree have labels. So, what are the labels in the tree that we have just drawn? A, B, C, D, E, F, G, H and I. We have used these labels in the tree that we have drawn. So, label is basically the name given to a node. These can be considered as labels N, V, P, etc., and there are various XPs associated with it like NPs, VPs, PPs, etc. So, there are two different kinds of nodes, root node and terminal node. So, the first node of a tree is basically the root node, and as you can easily infer, there can be only one root node in a sentence. You cannot have two root nodes, and basically you can define root node in the following manner. Root node is the node with no top line on it, and the end of a tree has nodes that do not have any line underneath. These are known as terminal nodes, and you can define terminal node in this manner. Any node with a branch underneath it is a non-terminal node. So, if you have a branch underneath some node, it is a non-terminal node, and if you do not have a branch, it is a terminal node. So, now I have a very basic task for you. Please go back to the tree and identify the terminal and non-terminal nodes in the tree. Now, we have to talk about some more structural relations in the tree. The first relation that we will be describing is dominance. So, for some of you the notion is known, right. You know that there are some nodes which are in higher position. What do we mean by higher position? Some nodes are higher than the other nodes in a tree. So, remember we are talking about a hierarchical tree only, and we are basically defining different components of it. So, you can easily figure out that whenever you are drawing a tree, there are some nodes which are in a higher position than other nodes. So, we know that trees show some kind of hierarchy of constituents, and if we can talk about the idea of dominance, this is the way in which we can define dominance. Node A dominates node B if and only if A is higher up in the tree than B, and you can trace a line from A to B going only downwards. So, you think about any node in a tree that maybe that you have drawn, and if you are drawing an N from an NP, maybe NP goes to spec and N bar, then N bar goes to N and something else. So, N is basically occurring in a lower position, right. So, you can say that NP is basically in a dominance relationship. So, node A dominates node B if and only if A is higher up in the tree. So, NP is higher up in a tree from N, and we can trace a line from N to NP. Basically, if we consider from NP to N, it is going only downwards. So, if you again go back to the tree, you can figure out that there are some domination relations in the tree. There is also a notion of exhaustive domination. What do we mean by this? We can define it in the following manner. Node A exhaustively dominates a set of terminal nodes provided it dominates all the members of the set. For example, there is no member of the set which is not dominated by A. So, if the entire set is dominated by something, then we can talk about exhaustive domination. So, it is only in relation to a set. We have more definitions and concepts related to the idea of domination, and let us have a different definition of constituent at this point. You already know how to define a constituent. So, now we have a slightly different definition. A set of terminal nodes exhaustively dominated by a particular node. So, you know that if we talk about a constituent, it is under domination of some XP, right. So, that is why we are talking about the idea of domination and the idea of exhaustive domination while defining a constituent in a different or newer way. We will talk about the idea of immediate domination at this point. Node A immediately dominates node B if there is no intervening node G that is dominated by A, but dominates B. So, there is this idea of intervening node. So, please be careful of this idea of intervening node, because this is important for us, and when we are talking about immediate dominance, immediate domination, we are basically talking about something where there is nothing coming in between the two nodes. So, it is important for us to know. And let me also tell you that we often use these terms mother and sister, for example, like a family tree, to talk about certain relationships. So, we can say, for example, A is the mother of B if A immediately dominates B. So, you know the definition of immediate domination now, and we do use the term mother in case of immediate domination only. And similarly, we can use the notion of sisters. We can say that two nodes that share the mother are called sisters. For example, in NP, so we can say that spec and n bar are sister nodes. Along with the idea of immediate dominance, it is also important for us to know about immediate constituents. I am sure some of you are familiar with this idea of immediate constituent if you have done the immediate constituent analysis, popularly known as IC analysis. It is already familiar to some of you. So, how do we define immediate constituents? We can say that B is an immediate constituent of A if and only if A immediately dominates B. So, with the idea of immediate domination, we are talking about the idea of immediate constituents. Along with the idea of dominance, it is also important for us to know or learn the idea of precedence. But there is a difference. We talk about dominance only in terms of a hierarchical structure, but we talk about precedence in case of linear orders. There is a basic difference. So, for example, if you talk about this rule M goes to A and B, you are talking about a linear order, right. So, we are saying that A must precede B in linear order. So, precedence is in terms of linear order and dominance is in terms of hierarchical order. This is something that we have to remember. So, at this point I am asking you to think about the explanation of a similar rule in terms of a hierarchical structure. So, M goes to A and B, this is a linear order that we are considering for discussing the idea of precedence, and we will have a revised and better definition of precedence now. But before that, how will you explain the same idea for a hierarchical structure? If you say M goes to A and B, if you can quickly draw the tree where M is basically dominating A and B, right. You can talk about more notions. So, how are we defining precedence now? We can say A precedes node B if neither A dominates B nor B dominates A, and A or some node dominating A sister precedes B, it is a sister and also preceding it, or some nodes dominating B. So, this is it is useful if you can break the definition in different components and then try to read it, it will be easier. We can then emphasize on different components one by one and learn about the definition in a better way. So, we learnt about the difference between dominance and precedence. Now, we will come to an entirely new definition, which will be again using some idea of dominance differently. So, this is the idea of C command. C command means constituent command, and we will be talking about the definition of constituent command now. So, we can say a node C commands its sisters and all the daughters. So, just try to visualize a tree in front of you. If node A is there, it is C commanding, which is a relationship, its sisters which are at the same level, and the daughters and daughters of its sisters. So, something which is dominated by the sisters. So, daughters and granddaughters and great granddaughters etc. of its sisters. So, this is the definition of sycamand. There are more definitions of sycamands, but it is better for us to stick to this at this point, because this is simpler and we can talk about the relationships as well, like sister and the daughters etc. So, there are differences between symmetric sycamand and asymmetric sycamand. It is important for us to know about the differences as well. What do I mean by symmetric sycamand? We can say A symmetrically sycamands B if A sycamands B and B sycamands A. So, if we go back to the definition of sycamands, we can see that A can sycamand its sister, right. So, if B is a sister of A and A sycamands B, B will also sycamand A because it is the sister relationship. So, it has to be understood by us. So, this is a symmetric sycamand. And then there is another definition of asymmetric sycamand. What is it? A asymmetrically sycamands B if A sycamands B, but B does not sycamand A. So, you think about a sister's daughter or sister's granddaughter, you can think about the relationship of a asymmetric sycamand. So, A can sycamand the sister's daughter, but the sister's daughter cannot sycamand A. This is a relationship of asymmetric sycamand. So, these are new definitions. So, it is advised that if you spend some more time and also go through the key reference that I will suggest and read, it will be easier for you to figure out. And while reading about the newer definitions, it is advised or suggested that you start drawing trees by yourself along with the learning of new definitions. It will be super easy. So, now I have a point for you which I am asking you to consider and think about it. So, how is the relation between different nodes that are involved in the sycamand relationship? So, this is something that I have also started discussing briefly. So, for example, sisters and sisters daughter, and whether it is a asymmetric sycamand relationship or symmetric sycamand relationship. But because this is slightly complicated in terms of the geometry of trees, so it is advised that you pause at this point, read them again and try drawing them in order to identify the relationship between different nodes. So, here I will ask you to draw some more trees, not only to identify relationship, but also to continue the practice of drawing trees, which will be fun, I am sure. So, there are these 3 examples. The thin cat from Kharagpur loves milk with biscuits. Now, you can actually draw with the X bar schema, it will be easier for you, and consider either IP or TP for sentences, and then use spec and I bar and I and VP, and then you have other components like adjuncts. It is your call to incorporate the adjuncts. If you have more than one adjuncts, what will happen, and how will you accommodate complements and adjuncts together if you are trying to draw them. So, it is your call to think about the structure of the sentences. So, I am asking you to do several things at this point based on your previous learning. First, draw a hierarchical tree and also draw a linear tree if possible. So, think about the idea of the complements, adjuncts etc., and intermediate projections in terms of X bar schema, and try to think about the different relationships that we have learnt in today's class. That is why I am asking you to draw trees at this point. So, the second sentence says Neeta said that Sita learnt a song from Spotify, and here you need some help of the functional categories that are anchoring words. You have already learnt about them in the previous class. And the third example, the extremely tired students loved syntactic trees with a passion. I am not telling you the exact the clue for the exact puzzle, but there is something which you had learned in the previous class, and it will be useful for you to identify them in the tree. So, I am asking you to draw the trees, identify the nodes. When I am saying identifying the nodes, I am talking about root nodes, terminal nodes, because we have basically learnt a lot of different definitions in today's class, right. A lot of new definitions can create confusion. So, that is why let us come back to basic tree drawing, and along with the revision of some previous notions that we have learned like adjunct, complement, etc., it is important for us to stick to today's learning as well. So, identify the nodes, both root and terminal as well as non-terminal, and also think about different relations between the nodes. After drawing each and every tree, you can make notes for yourself that relationship between these and this node is a sister relation or a sycophant relation or whatever you can identify. So, we are coming to the conclusion for today's class, and we have actually done a number of new definitions. So, it is very important for us to revise along with the revision of previous lectures. So, I will request you to spend some more time for today's class, because a lot of new definitions learned together. So, trees can be interpreted in terms of certain relations that we have learnt. We learnt about branches and nodes and different types of nodes as well. We learnt about labels. We talked about the idea of dominance and precedence, and also dominance is related to hierarchical structure, precedence is related to linear structure, etc. And in relation to dominance, we talked about the idea of constituent command or sycophant, and we learnt about different types of sycophants. So, quite a lot new definitions and learning for today. So, I will stop here and request you to go through all these definitions carefully, and this is the key reference for today's class. Thank you.